Now, the other thing for this lesson we're going to look at is even and odd functions, which actually come up in chapter 11, but they're relevant for chapter 10 because we've just done trigonometric graphs. So we're going to take a look at them here. This would have been covered in Algebra 1, but it would have been a while ago since you did that. So let's look at a few of the definitions here. So an even function. So what you do is you take a function f of x, and wherever it says x, you plug in negative x. You go ahead and simplify. If you end up with what you started with, that's called an even function. That's if you do it algebraically. Now, if you want to do it graphically, then you just take a look at the graph. If it's symmetric in the y-axis, that means it's even function. So there's a couple of different ways you can do these questions, depending on how well you know the graph in question. Now, if we look at odd functions, then if you plug negative x into the function, then actually you end up with a negative of what you started with. Now, if that happens, then you have an odd function. Or you could look at the graph, is it 180 degrees rotation about 0, 0? So in other words, if you took your graph, looked at it upside down, does it still look the same? And there's one more possibility. It could be neither of those two things. If it's not symmetric in the y-axis and it's not the same upside down, then it's neither odd or even. So that's also a possibility when you're doing those questions. Now, we did a little activity here, so we're going to do this one as well. Just move these out of the way so we can actually see. And we're going to look at some trig functions, and we're going to try and determine, are these even or odd? So sine x, is that even or is that odd? So sine x, the graph of it looks like this. And if we use some of our tools on here, oops, perhaps I shouldn't have drawn on there. There we go. If I turn this upside down, you can see that it looks exactly the same. So if you rotate this around 0, 0, you end up with the same graph. So that actually tells you that sine x is an odd function, which is what the answer says here. Okay, next question. Cosine x, is that an even or is that an odd function? Well, if I go ahead and draw that, I could try looking at it upside down. That certainly doesn't look the same, so it's certainly not an odd function. It is symmetric about the y-axis. You can see this part here and then this part here. So this one should be an even function, and indeed it is. If we go to the last one, tan x, is that an even or an odd function? If I draw it, it looks a little bit like this. And if we twist that upside down, you can see that that pretty much looks the same as what we had up here. So tan is an example of an odd function because it looks the same if you rotate it 180 degrees. So that one would be an odd function. And that's the last of those questions. Now, if you don't know the graphs, you can also look at them algebraically as well. So if we look at our first example, 2x to the power of 4. Where it says x, we replace it by negative x. Now, if you do negative x to the power of 4, negative times negative times negative times a negative turns out to be a positive, and then x to the 4 is x to the 4. So you end up with what you started with, and that's the definition for an even function. Now, for this one here, you might actually know what this graph looks like anyway. X to the 4, with it being an even power, is going to be your U shape, and with a 2 at the start means that's going to do the vertical stretch like we looked at last lesson. So I have the graph here for 2x to the power of 4, and you can indeed see that it does look symmetric about the y-axis. So there's more proof that that one actually is an even function. If we look at our second example, I could just have chosen x cubed, and if you can visualize that, you can probably see straight away that that's an odd function because it looks the same upside down. So I chose one slightly more complicated, x cubed minus x. So if you plug in negative x here and cube it, negative times a negative times a negative is still going to be a negative. If we do the negative of negative x, that becomes positive x. And then look what happens. X cubed becomes negative x cubed. Negative x becomes positive x. So actually we've got the negative of what we started with. Therefore, that's the other definition for an odd function. Now, if we look at the graph for this one, and I should be able to switch this around, you can indeed see that it does look the same upside down. So that's another example to prove that that is an odd function. Those two back, and then we'll look at our last question. Actually, for the last one, I think I might have messed up on this one. Let me have a look. x cubed plus 1. So if we plug in negative x into here, negative times negative times negative is a negative, and then plus 1 is still just plus 1. Now we can see that it's not the same, so it's not even, and the first term and the second term here, these are opposites of each other, but notice the 1 and the 1 are not opposites of each other. So that one's neither even or odd. And if we take a look at the graph for this one, well, you can certainly see it's not symmetric in the y-axis, otherwise it would go up here. But also, if we rotate this, similar, but look at the intercept. On this graph, it's negative 1. When you put it the other way, it's positive 1. So that also shows that it's not odd. So therefore, it's neither even or odd. So that would be a good example of something that is neither.